All right, you have 9 horses. A, B, C, D, E, F, G, H, and I. Let's start with conditional probability. Okay, so let's say we want to know the probability of winning if you choose any 3 of these horses. Those guys actually winning the race. All right, so let's start with the first horse comes in. Okay, the first horse actually comes in. We got our first place finisher. Now, what's the probability of that horse being on your card? You get 3 names on your card. The probability of the first horse being on your card is, well, 3 out of 9. So the probability, let's say, win 1 is 3 out of 9. Okay. Now that second horse is coming in, right behind them. What's the probability of that horse being on your card? Well, that probability of the horse being on your card is 3 out of 9, but that's not really what we're interested in. We're interested in what's the probability of the second horse coming in, knowing that your first horse also came in. Okay, well now, knowing your first horse came in, now you only have 2 spots left on your card, and there are 8 horses, so that's 2 out of 8. Okay, and if you want to say the probability of both of your horses coming in, so probability of W1 and W2, oops, I don't know why I put A there, and W2 is just equal to the probability of W1 times the probability of W2 knowing W1, which equals 3/9 times 2/8. This will cancel to 1/4. This will cancel to 1/3. This 1/12. Okay, so 1/12 chance that your first 2 come in. All right, now what's the probability of your third one coming in, knowing that your first 2 came in? So knowing probability of W1 and W2, that they both happened. And that is equal to, that's going to be, let's see, we got our third one. You only have 1 spot left on your card. And that spot left on your card, there are 7 horses to come in, so 1/7. Alright, so we know that the probability of your first one winning, and your second one winning, and your third one winning is equal to, well, that's going to be the probability of your first 2 winning times the probability of your third one winning, knowing that your first 2 won. And that is equal to, let's put the equals over here. So that is equal to, so W1 and W2 is 1/12 times the probability of the third one knowing the first 2 happened is 1/7, and that is equal to 1/84. That's great. All right, let's try using combinations. All right, so we've got, again, A, B, C, D, E, F, G, H, and I. Using combinations, we can say, how many different ways can you choose? So if the race is on, how many different ways can 3 horses get in first, second, and third in any order? Right, so that you have 9 horses. There are 3 different ways choose 3 different ways that you could have the 3 in any order. That is equal to 9 factorial over 6 factorial, 3 factorial, which equals 7 times 8 times 9 over 3 times 2, which equals 84. All right, and if you're boxing, that's exactly what you want. You just want your 3 that you chose to come in any order. It doesn't really matter what the order is. So there's only one of those combinations that's going to be correct to you, because we're not saying permutations. We're saying, like, if it chose D, E, and F, or F, E, and D, that's all just one choice. Okay? And so you have 1 chance. The probability of winning is just 1 chance out of 9 choose 3, which is 1 over 84. Let's try permutations. Permutations now, we're saying the number of different ways that they could, so let's say the horse track needs to know who's first, who's second, and who's third. Well, now we have 9p3 different ways that could happen, right? And so that is equal to 9 factorial over 6 factorial, which is 7 times 8 times 9. 560, 504. Okay, that's all the different ways that the race could get a first, second, and third. Now since you've boxed, you actually have 6 different ways that you could win, right? You could have 3 factorial different ways that you can win because you get all 3 factorial combinations. So the probability of winning in this case is 3 factorial over 9p3, which equals 3 times 2 over 504, which equals 1 over 84. All right, let's try a branch. Let's try solving it using a tree diagram. All right, so the probability of winning of the first horse coming in. So you got that first horse, win 1 happens, right? And that's you got a 3 in 9 chance. Once that first horse comes in, the chance of it being on your card is 1 in 3, or 3/9, right? And 6/9 of the time, you're just going to be a loser, straight up loser. Okay. Now the branch continues. The probability of getting it on the second one, knowing that you have it on the first one, so now there are 8 horses left, and only 2 can possibly make it because you've already gotten it on your card, right? And the probability of a straight up loss now will be 6 out of 8. But if you do happen to win on those first 2, well, what's the probability of winning on the third as well? Well, now you've got 2 crossed out, you have 1 left, there's 7 horses, so you got 1 out of 7. Right? And then so your probability of all 3 of those things happening are 3 out of 9 times 2 out of 8 times 1 out of 7, which is equal to 6, this is going to be 1 over 84 again. All right, let's now try a spreadsheet with experimental probability. All right, so here you can see I've made an Excel spreadsheet. I've put 1, 2, 3, 4, 5, 6, 7, 8, 9. So basically all the different horses here. And then I randomly chose 3 of those horses. So I basically put those numbers in random order and boxed off the top 3. So here, so you can see 3, 8, and 4 are my randomly chosen horses. Now every time you open this, oh, there, it just switched to 9, 1, and 3. Every time you do something to this sheet, it switches those horses. So it does another random sample of it. Right now, at the bottom here, so you can see that I just randomly did races. So these are all different horse races that could happen. And again, it's just the random numbers from 1 to 9. You can see here the winner was 9, 1, and 7. I almost won. 9, 1, and 3 was what I boxed, but this is a loss. Here, 1, 6, and 8, not even close. So these are all the different races that I did. You can see there are 25 races. There were 0 wins and 25 losses for those. Let's see, if we go down a little bit, 0 wins, 25 losses. Oh, there's a win here. 1 win, 24 losses. Let's check out that win, if we can find it. Oh, there it is. So if I go up, see, you notice the first, second, and third is 3, 9, 1. And if you go up, we have 9, 1, 3. So yeah, our 3, 1, our box wins there. And I just did a whole bunch of races. Let's see what else we got here. We got 0 wins. Oh, there's a win up there. Right here. We got a win there. Every so often you get the correct 3 horses, right? So you got a bunch of 1s and 0s. Let's see where our win is over here. Say, if I can find it. Oh, there it is. So 1, 3, 9. If we go, what else? There's another one here. Oh, there it is. You got 3, 1, 9. So anytime you have 9, 1, and 3, you get yourself a win. All right, so here we had 175 total wins and 14,075 losses out of 14,250 trials that I did. So I filled this thing up, and there's the probability of a win. And this right here, this 0.011904761 that's just 1 out of 84. 1 divided by 84. So that's the actual theoretical probability of winning. And you can see that, 0.01228 is pretty close. Okay, so I copied that 0.01228 here. The probability of a loss is 98.8%, you can see. And every time I just do something, so I'll just put like equals, I'll just do anything right here, and that'll make it recalculate. So just like equals 1. If you go up, 913, 231 now we have. So what it's doing is it's recalculating, it's boxing new things every time it calculates something. So every time you open this spreadsheet, it's going to do the same thing. It's just going to recalculate. So now you can see our probability changes a little bit. So now we have 231, and our new probability is at 0.018456. So it's like 1.8%. I just did another, just changed it. Now 1 and 6 and 4 are the ones we boxed off. Give it a second, and let's see what this new probability will be. Oh, now it's 1.5%. So you can see it's hovering around, well, I know that it's 1 out of 84, so the probability should be somewhere in that region. Right. Okay, that's about it. I could play around with that more if I want, but that's basically the idea.